at -6 seconds, we will see the disconnection of the upper stage, these big cryotechnic arms you can see on this picture. Then, 3 seconds before the H0, the inertial platform that will give all the information about where it is to the launcher will be released. And at H0, the 7-second sequence to ignite the Vulcan engine of the main stage will start. That will take 7 seconds, a little less than 7 seconds, where the engine will start up to its flight regime. Once the computer has checked that the Vulcan engine is running normally, and you will see at that point a flame going stable at the outlet of the nozzle. And at that point, the onboard computer will ignite the 2 boosters that will enable to move the 770 tons of Ariane and Webb.
Coming up on the T-4 minute mark right now. Just a couple of milestones real quick. At the 1 minute 5 second mark into the flight, Ariane 5 will go through the period of maximum dynamic pressure, max Q as it's known. That will be the period of maximum aerodynamic forces on the rocket itself. The solid rocket boosters, which will provide about 90% of the initial thrust off the launch pad, will shut down and separate at the 2 minute 21 second mark into the flight, followed 1 minute and 5 seconds after that by fairing jettison. That will expose the James Webb Space Telescope to the environment of flight for the first time. The main stage separation, or the first stage separation, comes at the 8 minute 47 second mark into the flight, and that will be about a 16-minute burn of that upper stage engine. It will cut off at about 24 minutes 51 seconds into the flight, and then we'll go into a coast phase of about 2.5 minutes to allow any oscillations to dampen out, provide the most pristine environment for the James Webb Telescope before observatory separation. We're coming up on the 2 minute 50 second mark into the flight. Again, you're going to be hearing critical calls down the stretch here from the DDO, or the Range Operations Manager, Jean-Luc Voyer. The weather is go. We have a green board, no issues being worked. NASA officials, including Greg Robinson on the right, carefully watching the telemetry, looking intently at the final couple of minutes of the countdown. Lives have been spent in the preparation of the James Webb Space Telescope that is about to fly.
And Beatrice Romero on his side, on the left of the screen, from Ariane Space.
And that is the DDO, the Range Operations Manager, Jean-Luc Voyer, as we have hit the 2 minute mark in the countdown.
The flight will be in 2 phases. You will see the first part of the flight during the solid rocket boosters phase. That will be the atmospheric part of the flight, the atmospheric flight, and the trajectory will be driven by a to reduce the aerodynamic loads, and we will have a very different exo-atmospheric flight after that.
And you were watching a number of people, VIPs and invited guests, moving out to the observation platform that is right next to the Jupiter Control Center as we stand by for the 1 minute call from Jean-Luc Voyer.
À tous les DDO, attention pour moins 1 minute. Top, à 0 moins 1 minute.
Thumbs up from Jean-Luc Voyer. All systems are go. We're inside a minute now, T-minus 50 seconds and counting. As you heard earlier, the Vulcan 2 engine will ignite. Turbo pumps will come up to flight speed for 7 seconds, and the command will be issued to ignite the solid rocket boosters. The James Webb Space Telescope will be on its way. T-minus 30 seconds and counting. Standing by for terminal count.
À tous de DDO, attention pour les décomptes finales. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top.
And we have engine start. And
Allumage
liftoff.
UAP, décollage.
Décollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe. Punching a hole through the clouds, 20 seconds into the flight. Good pitch program reported.
Trajectoire est nominale.
Vehicle performance is nominal. The Ariane 5 rocket continues to fly uphill in nominal fashion. The rumble of the powerful Ariane 5 now being felt here in the control center. 3D animation.
We can hear the noise and feel the vibrations here. You're right, Rob. Yeah, impressive.
13 kilometers in altitude, 7 kilometers downrange, traveling about 0.6 kilometers per second.
Tous les paramètres à bord sont normaux.
The trajectory reported to be nominal by Jean-Luc Voyer, the range operations manager. You can see at the bottom of your screen, the yellow line is the trajectory plot, perfectly overlaid over the green line, which was the pre-launch trajectory. 1 minute, 41 seconds into the flight, about 40 seconds away from shutdown of the solid rocket boosters. Coming up on the 2-minute mark into the flight.
When it detects the threshold on acceleration, not the deceleration, but less acceleration for
Tous les paramètres à bord sont normaux.
Everything is okay, everything is normal.
2 minutes, 15 seconds into the flight.
When the computer detects this threshold, it will separate.
Séparation des EAP.
Done.
We have confirmation of solid rocket booster separation from Jean-Luc Voyer. This coming at an altitude of 44 miles. The Ariane 5 and James Webb traveling almost 5,000 miles an hour. We have about 1 minute, 5 seconds to go before fairing jettison. That'll be the next critical milestone.
The fairing is there to avoid the satellite being exposed to high temperatures and also high airflows. And as soon as the launcher leaves the atmosphere, as is now the case, the satellite does not need anymore to be protected, and Webb does not need anymore to be
Paramètres à bord sont
protected.
normaux.
So each kilogram being very important for the performance of the launch, we are going to eject this no more useful fairing.
And let's go down to the floor in the Jupiter Control Center to Raphael Chevrier of Arianespace. Raphael, so far so good.
Hi, Rob. So far, so good. Everything is nominal, as we say when attitude and trajectory of the Ariane 5 is going perfectly well. As you can see also on the yellow line
Lagage de la coiffe.
on the screen, we had the confirmation of the separation of the two solid boosters and now of the fairing, meaning that we have crossed the limits of the atmosphere. So everything is going
Tous les paramètres à
super
bord sont
good.
normaux.
And the DDO just said that all parameters are going perfectly smoothly. So let's continue the mission.
And Raphael, this is a view from the upper stage camera called the Vicky Cam, looking back at the James Webb Space Telescope. This is on about a 20-second delay or so because of the way the imagery is processed here in the control room. There's your telescope ready to unfurl its wings basically and begin its journey to the Lagrange point, the L2 point, about 1 million miles away from Earth.
La trajectoire est nominale.
Trajectory is nominal. The report from Jean-Luc Voyer. The liftoff time confirmed here in the Mission Control Center at 12:20 Greenwich Mean Time, 9:20 a.m. Peru time, 7:20 a.m. Eastern Time. The The Ariane 5 and James Webb, 181 kilometers in altitude, 450 kilometers downrange from the launch site here in Kourou.
Flight control is very smooth.
5 minutes, 12 seconds into the flight. We have about 3.5 minutes to go in main stage or first stage performance. And again, you can see at the bottom of your screen the yellow plot line overlaid over the green line, meaning we are right on course, right down the pike, and a perfect trajectory so far for the Ariane 5 rocket.
All telemetry data are now received by the Galileo tracking station, which is close to here, where we are in Kourou. It will track the launcher up to the ignition of its upper stage. And then we'll have the Natal station in Brazil, Ascension, as you can see on the map, in the middle of the ocean, and the two last stations in Africa, Libreville and Malindi, one on the east coast, the other one on the west coast. And the one on the west coast, Malindi, you can see that the telescope will be separated more or less over this Malindi station. And this Malindi station will also acquire the telemetry data from the telescope. You can see both are green, Galileo and Natal on this animation. It means they are expected to receive the data, and it was confirmed right now by the launch operations manager.
Acquisition de la télémesure par la station de Natal au Brésil.
And just confirming now that telemetry is being processed through the Brazilian tracking station. The telescope is also processing telemetry through the tracking and data relay satellite system. As it moves further and further out into deep space, all of the telescope's telemetry and its imagery ultimately will be processed through the Deep Space Network in Goldstone, California. We passed the 7-minute mark into the flight. A perfect ride so far on the Ariane 5. We have about 1.5 minutes to go in the first stage performance. Once the main stage engine is commanded to cut off, it will be jettisoned, and just a few seconds after that, the upper stage engine will ignite, and it will be the workhorse for a 16-minute burn that will put James Webb into its preliminary orbit. About 11 minutes from now, telescope controllers at the Space Telescope Science Institute will be sending commands to prepare James Webb for the initial series of commissioning activities that will lead to the deployment of its solar array and the initiation of generation of electrical power for the telescope. About 30 seconds away from main engine cutoff.
La trajectoire est normale.
Nominal trajectory continues to be the watchword for the day from the Range Operations Manager, Jean-Luc Voyer, as we stand by for main engine shutdown and separation.
Extinction de l'EPC. Préparation EPC.
And we have main stage shutdown and separation confirmed here in the Mission Control Center, and the ignition of that upper stage. And Raphael Chevrier down in the fishbowl. So far, so good.
Yes, Rob, we have the confirmation of the separation of the main stage and the ignition of the upper stage. The trajectory is perfectly nominal. This is a very important moment for us because it's always a challenge to switch on a cryogenic engine in space condition, and we are now at 220 kilometers of altitude. Speed is a bit more than 7 kilometers per second. As we enter now the second stage of the second phase of the flight, the upper stage is going to power for about 16 minutes to place Webb on its transfer orbit, and right now everything is again nominal, as the DDO just said.
And a short time from now, the so-called Sawtooth Maneuver will get underway. Again, like rocking a baby in a cradle, this will be a maneuver to keep Webb's optics protected from overheating, Luce.
Exactly, Rob, like a baby in a cradle. You can see here Webb attached on top of Ariane 5 upper stage with a very specific configuration. Of course, it will be different during its lifetime, but for the time being, its sun shield is folded and not yet fully protecting the observatory. A number of exhaustive studies have been performed by the mission teams in Europe, in the US, on the thermal conditioning inside the telescope and the way the rays of the sun would propagate and interact with sensitive equipment inside the telescope. Maintain this thermal conditioning is really key before separating this telescope. And in particular, we know that one face of the telescope cannot face the sun. That's why and to produce these right thermal conditions inside Webb, a specific roll law has been designed, what we call the Sawtooth Approach. And if you are watching carefully to these images, you can see this animation. You can see that the upper stage is going 30 degrees on one side, then 30 degrees on the other side, going back and forth this way to maintain this perfect thermal conditioning for the telescope.
It's worthwhile noting that after Webb separates from the upper stage of the Ariane 5 rocket, which continues to perform in excellent fashion coming up on the 12-minute mark into the flight, the telescope controllers will be taking the baton, if you will, from the mission controllers here in Kourou. The first steps will be the opening of fuel valves, a pair of fuel valves, to start flowing fuel to Webb's onboard thrusters. They then will power on the valve drive electronics. Those are powered on in preparation to control and fire those thrusters when required. Webb's solar array is scheduled to be deployed at approximately the 33-minute mark into the flight. Once it is locked in place, we'll get the call that electricity is flowing through the array. That call will come from the Mission Operations Manager, Carl Starr, who is at the Space Telescope Science Institute at Johns Hopkins in Baltimore. Seated right behind him in that control room is Alicia Starr, a pair of stars helping to guide James Webb on its discovery of the stars. Alicia Starr is the lead engineer for launch and ascent events. Once the solar array is deployed and declared power positive, then 3 out of the 4 hold downs for the aft deployed radiator will be released to prevent binding due to the cool down of the telescope's composite structure. The contamination control heaters will be enabled to protect instrument optics on Webb from any water ice condensation as they cool down. The actuator drive unit will be powered on. This particular mechanism helps with heater control of the fine steering mirror, preventing water ice condensation later to be used to position each of the mirror's segments. All 6 reaction wheels and the wheel drive electronics will be powered on for Webb, and that will be the precursor to the attitude control system using those reaction wheels to maintain the proper orientation with the sun, as opposed to using onboard thrusters. Of course, fuel in those thrusters, very valuable. It's a limited commodity for the lifetime of James Webb's observations of the universe. We're 13 minutes, 55 seconds into the flight. Jean-Luc Voyer, the Range Operations Manager, continues to report a nominal performance for James Webb. And again, Luce Fabregat from the European Space Agency, how is this trajectory being carefully and methodically adjusted to provide the correct parameters in the final stages of ascent?
Yes, Rob, as you can see on this plot, the altitude is slightly going down. It's perfectly normal. The launch vehicle is really on the line where it should be. This decrease of its altitude, slight decrease of its altitude, will allow the launcher to benefit and the upper stage to benefit of the gravity effect. and to increase its velocity until it reaches a thermal threshold. It's about to reach it, or even already reached it now, and it will go up. And now it will go up and up to the separation of the Webb telescope. It will separate the Webb telescope on a highly elliptic orbit, but still around the Earth. The telescope will be released, inserted on an orbit around the Earth with an apogee, a very high apogee above 1 million kilometers.
Trajectory nominal as reported by Jean-Luc Voyer. You see him in that view, 185 kilometers in altitude. Some 4,500 kilometers downrange from the launch site here in Kourou, moving at more than 8 kilometers per second, right on the plot, right on the trajectory, everything looking great. We are about 9 minutes away from the completion of upper stage ignition. It's shutdown, and then about a 2.5-minute coast phase before Webb will separate. Observatory separation will be called out. You'll be hearing those calls and the initial calls from Carl Starr, the mission operations manager at the Space Telescope Science Institute at Johns Hopkins, through solar array deploy and the declaration of a power-positive spacecraft. James Webb, of course, will be traveling well beyond the moon to a distance of about 1 million miles away from Earth, settling into a highly elliptical halo-like orbit to begin its astronomical observations. And again, as we mentioned earlier, at the time of observatory separation, Webb will be at an altitude of approximately 864 miles, statute miles, traveling some 21,000 miles an hour. We're about 8 minutes away from upper stage shutdown. The stage has performed as planned. No issues reported. The launch occurring at 12:20 Greenwich Mean Time, 9:20 Kourou time, 7:20 a.m. Eastern Time on this Christmas Day.
Very smooth launch. The velocity you just mentioned is very important, Rob. The velocity you just mentioned at separation of the telescope is very important. It will be slightly below, okay, I give it in a kilometer per second, but it will be slightly below 10 kilometers per second, because it's important that the satellite, the telescope, is not inserted on an escape orbit. It will be placed on a terrestrial orbit so that there will be time for the layout, for the early phase operations and the commissioning of the telescope. And that will be, in fact, the upper stage that will leave this orbit and goes toward an escape or liberation orbit.
And of course, even though we're still in powered flight, the trajectory, the acceleration, the speed at which James Webb is going towards its preliminary orbit, all modeled in advance and carefully choreographed to maintain as quiescent an atmosphere and environment around the telescope for its ultimate separation from the upper stage of the Ariane 5 rocket, which is about 6.5 minutes from now. Eighteen and a half minutes into the flight. It's very quiet now here in the control center here in Kourou. NASA officials, European Space Agency officials, Arianespace officials, all watching telemetry very carefully. And as the upper stage continues to burn nominally and sheds fuel, the acceleration uphill for the James Webb Space Telescope continues to increase as we approach the 20-minute mark into the flight. Again, upper stage cutoff is scheduled at the 24-minute, 51-second mark into the flight, about 5.5 minutes from now.
After the cutoff of this main engine, as you said, Rob, we will have a short ballistic phase, a short coasting phase that will, when the upper stage will rely fully on its what we call the attitude and roll control system, and it will adjust its attitude so that during this small ballistic phase, all the requirements from the telescope are fully met, and that at the separation, when there will be the separation, the conditions will be very smooth and as requested for the telescope.
Le pilotage est
beginning
calme,
of
la
life.
propulsion est nominale.
Today's countdown was as flawless as you can imagine. The weather was perfect all the way through the early morning hours, through the fueling process of the vehicle. The weather's been a bit dicey here in Kourou over the past few days, but everything fell together on this Christmas day to send a new present to the world's astronomer. 20 minutes, 40 seconds into the flight.
Trajectoire est normale, tous les paramètres à bord sont normaux.
All parameters nominal, as reported by Jean-Luc Voyer, the range operations manager. 4 minutes of powered flight remaining.
The telemetry of the launch vehicle is acquired for the time being by the Libreville tracking station on the western coast of
Trajectoire est
Africa.
normale.
Flight control is nominal. The trajectory is fully normal, fully as expected, as you can see on the plot with the yellow plot over the green one. That is the expected one.
22 minutes into the flight. Less than 3 minutes of powered flight
Pilotage
remaining.
est calme.
Smooth flight control.
And again, as we've mentioned
Tous les
before,
paramètres à bord sont normaux.
everything nominal reported by the range operations manager. As we've mentioned before,
Acquisition de la
this is a
télémesure par la
long
station du
ride
Malindi
uphill
au Kenya.
for the James Webb Space Telescope to put it at the proper position in the sky so that it can escape from the Earth, basically head beyond the moon towards its final orbit for its commissioning activities that will be the dominant feature of all of the operations from the Space Telescope Science Institute over the course of the next several weeks.
And the launch operations manager announced the acquisition by Malindi, by the Malindi station, as expected, for the end of the flight and the last part of the upper stage flight and the separation of the telescope.
James Webb is about 4 minutes away from separating from the upper stage. And again, at that point, it will be on its own. And again, those milestones that we discussed a bit earlier in the broadcast will begin to be followed carefully by the telescope controllers at the Mission Operations Center, the MOC as it's called, at the Space Telescope Science Institute in Baltimore. 1 minute of powered flight remaining. The upper stage continues to function perfectly. It's been a smooth ride for the James Webb Space Telescope.
Trajectoire est nominale.
That upper stage was loaded pre-flight this morning with 15 tons of propellant for this long 16-minute burn. Now about 30 seconds away from upper stage cutoff. we're standing by for upper stage shutdown and the cutoff of the upper stage engine.
Extinction ESC. Les paramètres à bord sont normaux.
The extinction of the shut-off of the cutoff of the engine was confirmed exactly as expected, with the exactly expected altitude and speed and velocity. So now we have entered the coasting phase, the ballistic phase, that will last for a little more than 2 minutes.
And the telescope controllers in Baltimore confirming that all of the function parameters for the James Webb Space Telescope have been loaded on board the telescope. We are expecting Webb separation at the 27-minute 7-second mark here into the flight. Just over a minute from now, springs will gently push Webb away from the upper stage of the Ariane 5. As it moves further and further away from the upper stage, there'll be what we refer to as a collision avoidance maneuver.
Yes, Rob, exactly. The springs already will give some distancing, of course, between the two objects, between the telescope and the upper stage. And then the upper stage will leave the trajectory of the telescope and makes a special maneuver to pass the telescope and heads towards a liberation orbit and leaves the telescope on its orbit without any risk of collision and without any risk of pollution towards the telescope.
And we're about 17 seconds away from Webb separation.
Séparation Webb Space Telescope. Go Webb!
We do have confirmation of observatory separation. The James Webb Space Telescope, amidst applause here in the Mission Control Center, now taking its first steps in pursuit of cosmological discovery. It was a perfect ride to orbit, and all of the separation sequence events are running in good fashion according to the telescope controllers. And there is the view from the upper stage camera on the Ariane 5 looking at the James Webb Space Telescope as it moves gently away from its launch vehicle.
Fantastic pictures of this telescope.
Go Webb, go Webb.
Yes, go Webb.
Ironically enough, as we marvel on this view from the upper stage camera, this will be humanity's last view of the James Webb Space Telescope as it moves to its workplace about 1 million miles away from Earth.
Yes, you're right, Rob. Yeah. Impressive, fantastic pictures. Yeah.
Now we'll be hearing shortly from the mission operations manager at the Space Telescope Science Institute, Carl Starr, who will be calling out the procedures that will lead to the deployment of Webb's solar array. And down in the fishbowl where there is jubilation, let's go to Raphael Chevrier of Arianespace. And before we do that, Raphael, a bit earlier than planned, but there is the solar array having been deployed. James Webb now has its array out as we stand by for confirmation that it is power positive.
Hey Rob.
Ah, c'est incroyable.
J'entends pas ce qu'il me dit, Rob. Il m'a appelé ou pas? Il m'a appelé ou pas, Rob?
Non, il t'a pas appelé.